We're going to look at problem number 5 on page 23, section 1.2. I'm going to click on text within Maple, and I'm going to type in which problem we're doing. And now I'm going to click on the Math button, and I'm going to want to identify the matrix. I'm going to use I'm going to invoke a depreciated package called linalg. So I say with parenthesis linalg colon. I can use a semicolon, and the semicolon will actually give me all of the information about the linalg package in terms of items that are available under that package. I'm going to use the colon to suppress that output. Now I'm going to define my matrix in number 5. So I'm going to say A colon equals, and I'm going to go down to the matrix palette, and I note that the matrix, I have 3 equations with 3 unknowns and then a column with constants. So it's a 3 by 4, 3 rows, 4 columns matrix. And I'm going to now enter the coefficients using the tab button on my computer. And now I need to get out of the matrix, so I'm going to use the right arrow button on my computer and then put a colon once again just to suppress the output, because I have already got it typed in here. I don't need to see it again. And in a few seconds, there's my matrix. So now I'm going to use mul row, add row, and swap row if needed to be able to use the Gauss elimination process. Now all this is going to do is do the computations for me so that I don't make an arithmetic error. It shows your instructor that you do know the process for Gaussian elimination. So the first thing I'm going to do is I'm going to rename the matrix A, and what I'm going to rename it to is I'm going to look at the first element here, the A11 position. I note that it's a 1, so I want to get zeros completely underneath it. So I'm going to, in my first step, use the add row command. I want to use it on matrix A. I want to take row 1, and I'm going to do something to row 2. What am I going to do to row 2? Well, first of all, I'm going to take and add row 1 times 1 and then add it to row 2. So the last item there in that set of parentheses is what my multiplier is. And this time I can use either the semicolon, or just say enter, and it will go ahead and give me my new matrix. And you can see that the 0 is in the A21 position. Now I need a 0 in the A31 position. So once again, I'm going to say A colon equals, and I'm going to use the add row command again. I'm going to work on matrix A, which is now this matrix. I'm going to again use row 1. I'm going to multiply row 1 by -3 and then add it to row 2. And hit enter. And that was a mistake. That should have been row 3 that I'm adding it to. Now notice how this got all screwed up. So I'm going to, and I did this on purpose so you can see what happens in Maple. Although Maple is very powerful, if you screw something up, you do have to make adjustments. So I'm going to highlight all of this, and I'm going to go to the top arrow here, the top exclamation point, the single exclamation point, and I'm going to hit it. And what that will do is rerun all of that. So now I'm going to go down and I've got my zeros under the first column. I've got the zeros underneath the 1, so now I'm going to focus on the A22 element. This time I want a 1 in the A22 element, but I have a -1 there, so I'm just going to use the mulrow command. That's going to multiply a row by a number. So again, I want to use matrix A, and I'm going to take row 2 and multiply it by a -1, and you can see that that forced a 1 in that column and multiplied all the other entries along that row by that -1 as well. Alright, so now I have a 1 here. So I'm going to need a 0 in this position and a 0 in this position. So in the A12 position and in the A32 position, I need to get zeros there. So I'm going to use the add row command again. And this time I'm going to be working with the matrix A once more, but I'm going to be using my pivotal row as row 1. So I'm going to take, or row 2, sorry. So I'm going to take row 2, and let's get the 0 in the A12 position. So I'm going to be manipulating row 1. What am I going to do? Well, I'm just going to multiply entry, and I'm focusing on the entry. I'm going to focus on the A22 entry, multiplying it by -1 and adding it to row 2, multiplying it by -1 and adding it to row 1. And you can see there's the 0 in the A12 position. Now I need the 0 in the A32 position. So again, I'm going to use the add row command. Again, working with the old matrix A. Again, working with row 2. What do I have to do to row 2 to add it to row 3? Well, I see I'm -10 in the A32 position, so if I take the A22 position and multiply it by 10 and add it to row 3, I will get the 0 in that position. So you see now that we have the 1 in the A22 position and the zeros everywhere else. Now I'm going to focus on the A33 position. I need a 1 there. So I'm going to use not the add row, but the mulrow command. Again, working with the old matrix A, the previous matrix A. I'm going to take row 3 and multiply row 3 by a -1/52. And you can see how we now have the 1 in the proper position. So the A33 position is 1. We need a 0 in the A23 position and a 0 also in the A13 position. So to get those, I'm going to use once again the add row command. Working with the prior matrix A, this time I'm going to be working with row 3, adding to row 2. What do I have to do to get what I need? Well, in the A33 position I have a 1. I need to get this guy -5 to a 0. So I'm going to multiply by 5. And you can see that the A23 position is now a 0. Now I need this A13 position to be a 0. Well, it's a 7, so I'm going to use the add row command again. Working with the old matrix A, again working with row 3. What am I going to do? I need to multiply row 3 by a -7 and then add it to row 1. So you now see that the 3 by 3 matrix to the left of the constants there is the identity matrix. So I'm going to come over here and hit the text button, and we can say we read off the solution to be, if I looked along the first row, x is equal to 3. Looking along the second row, y is equal to 1. And finally along the third row, z is equal to 2. And that's our unique solution. Now, if any one of these rows drops completely to 0, then you will have an infinity of solutions. And if any one of the rows drops to 0 except for the constant item, you will have no solution.